In number 13, we want to evaluate the definite integral this time from 0 to 1 of x times the square root of 1 minus x squared dx. And so before you do that, before we worry about the definite integral part, we want to just find the antiderivative. And so we're really just going to find the antiderivative of x and then square root. Let's change that into the 1/2 power. And so this is what we want to find first, and then we'll come back and get the definite integral second. So this does have a composite function in it. So the inner function is going to be 1 minus x squared. And so we want to find the derivative of that inner function, which will be negative 2x dx. Now, if we look at this, we have the x part and we have the dx part. So the only thing that we're missing here is the negative 2, a constant multiple. And so what we're going to do in this case is just multiply the inner part by negative 2, and then we need to balance that by multiplying by negative 1/2 on the outer part. So this is how we multiply and divide to make du on the inner part. Now, when we go ahead and do our substitution, we'll have negative 1/2 times the antiderivative of u to the 1/2 and du. Okay, now we can take the antiderivative using the power rule. So 1/2 is going to go up 1 to 3/2, and then we're going to divide by that 3/2. And of course, we'll have a plus c. Now, we do want to simplify this. So instead of dividing by 3/2, we're actually going to multiply by 2/3, multiply by the reciprocal there. And so now the 2's will cancel. And so we have negative u to the 3/2 over 3 and the plus c. And then we're going to back substitute for u. So if you remember, u was 1 minus x squared. So we're going to back substitute right in there. So we have negative quantity 1 minus x squared to the 3/2 power over 3 and plus c. From here, we're going to go ahead and calculate the definite integral now. And so what we're going to do is we're going to have that antiderivative that we just found. And we're going to evaluate that from 0 to 1. And what that means is we're going to plug in 1 first, so 1 minus 1 squared to the 3/2 power over 3. And then we're going to subtract, and then we're going to plug in 0. And we're going to do 1 minus 0 squared to the 3/2 over 3. Now, a lot of times when we have 0, it ends up becoming 0. But with composite functions, that's not the case. So you do have to plug in the 0 there. So we'll go ahead and simplify this now. It looks like 1 minus 1, looks like we got 0 to the 3/2 over 3 here. The double negative becomes positive, and now this becomes 1 to the 3/2 over 3. And so we get 0 plus 1/3, or just 1/3.